Good day, everyone. Welcome to Life Sciences Grade 11. My name is Tutuzile Kupeka. The topic for today is gaseous exchange. We started this topic last week, actually. So today, I want us to continue with it and do some activities from the book. I use the textbook. I use the textbook as solution, no, via Africa Life Sciences. So you can I got it access it from Snaplify app. So if you do not have it with you, access the Snaplify app where you can access the Snaplify app on Google. You can Google it or you download the app. Ne? It's best if you download the app, then you can store all your textbooks there. You can make notes on the app, you can highlight, all of those things. It will really, really help you. And you can access any textbook. It doesn't even have to be this one, but it will help you as we move along with this one. The one I use here is via Africa. So the topic is gaseous exchange. We have some activities that we will be doing. So this image is extracted from stock Adobe, those images. Why am I showing you a candle? It's just the concept of trying to explain to you how gaseous exchange functions. So this here, the demonstration whereby you use a candle and we try to compare the candle's needs versus human needs. What are we burning here? When we burn a candle, what exactly are we burning? What is it that you're burning here? The more this candle is burning, what is it? What exactly is being burnt? There, let me show you the answers over this side. What is being burnt? When you burn a candle, you're actually burning the wax, right? The wax is being burnt. More wax is being burnt, you provide light. And then when all the wax is burnt off, it means there's no more light anymore, right? In the human body, you'll be burning what? You are burning food. So that's a similar concept. It's food being broken down. It's food being burnt. In the candle, you're burning down wax. What is given off? When you burn this candle, what is given off? You give off heat, as you can see here, the image of the candle. This is the heat given off the way the wax is burning. The wax is burning. The more wax burns, the more heat is given out. And then what gas is needed to keep it going? We all know the process of combustion, that no fire will happen unless there is what? Oxygen. So you need oxygen for this heat to be given off. So we need oxygen. So the candle will need an input of oxygen so that the wax can be burnt and heat could be given off. And then what gas is produced as a byproduct or waste product? It would be carbon dioxide because you are burning, you're taking in oxygen, but it's taking out what? Carbon dioxide. The same happens or applies to a human body. In the human body, we are burning down food and we are giving off heat. Giving off heat, what gas is needed? We need oxygen. Human beings cannot function or survive without oxygen. And then what gas is produced as a byproduct? It is carbon dioxide that you are producing as a byproduct. So you understand the comparison between the two. And then just a recap once again of exchanging gases in vertebrates. Exchanging gases in vertebrates, that's what we discussed last week, no? The differences between breathing, gaseous exchange, and cellular respiration. What is the difference between those three? Do you remember? Breathing is the physical and mechanical process where air is moved in and out of the lungs. We described that breathing, there is a physical and mechanical process, mainly physical, right? And mechanical process where the air is moved in and out of the lungs. But with gaseous exchange, it is a chemical process which involves the diffusion of gases at respiratory surfaces. So this is a chemical process. There are gases involved over here. There's a chemical reaction taking place. So these two right now, let's first compare these two. Inhalation is when there's air moving into the lungs and breathing system. And then exhalation is air moving out of the lungs and breathing system. So when you inhale, you take in the oxygen, and you exhale, you take out oxygen. So that's just the simpler part. Over and above breathing, there are more complex processes happening, which are gaseous exchange and cellular respiration. The one we know for a fact that you do, it's a physical one. You breathe in, you breathe out. That's what we know. But what exactly happens to this oxygen that you inhale and this carbon dioxide that you exhale? How did it come about? Those are explained further in the processes of gaseous exchange and cellular respiration. But please note the differences, even in the definitions and the functioning of physical process is the breathing. Air is moving in and out of the lungs. And then with gaseous exchange, this is a chemical process involving the diffusion of gases at respiratory surfaces. In lungs, oxygen to blood and carbon dioxide to alveoli. So here in this process now, this oxygen is moved to blood. Why? Because then the blood moves all over the body where it can then take the oxygen to where it is required in the body. To all those different organs or different parts of the body that require this oxygen. Then carbon dioxide to the alveoli, whereby it's going to be what? It's going to be excreted or exhaled rather. And then in cells, the oxygen is to cells and carbon dioxide is to blood. This is also when you explain in the deeper levels of the functioning of what happens in gaseous exchange, which we'll still discuss as we go on. And then cellular respiration, this is an aerobic metabolic chemical process. Aerobic metabolic chemical process. Aerobic meaning what? It's in the presence of oxygen. Metabolic, there's a breakdown or processing of food there, where energy-rich compounds are broken down in cells to release energy for metabolism. The requirements are what? Oxygen, and the products are what? Carbon dioxide. These gases are exchanged with the tissue fluid and blood. So here, the tissue fluids and blood are involved in this process over here. Then, next up, exercise 1. Oh, I gave you the answers. Anyway, exercise 1. By what process is energy obtained from food? We've seen here this process of cellular respiration. Cellular respiration, you break down food. Here you see energy-rich compounds are broken down in cells to release energy for metabolism. So what process is that where energy is obtained from food? It's through the process of cellular respiration. You'll notice with the breathing, it's just air moving in and out of lungs. With the gaseous exchange, that's the chemical process which involves gases. But in cellular respiration, that's where the metabolic chemical processes take place, whereby compounds, energy-rich compounds are broken down. So that one there, what that involves energy and food is what? Is cellular respiration. And then question 2, what is the intake of oxygen and the output of carbon dioxide at a respiratory surface called? It is called the gaseous exchange. Key notes here, key words here that you need to note before you confuse it. The intake of oxygen and output of carbon dioxide. It can be breathing, right? But they go on to say at a respiratory surface. Respiratory surface. Gaseous exchange occurs at a respiratory surface. So it's not just the breathing there. It explains here, in the chemical process that involves the diffusion of gases at respiratory surfaces. So that's the key points to note. Gaseous exchange occurs at respiratory surfaces, whereby there's an intake of oxygen and output of carbon dioxide. Then, question 3, name the process of taking air into the lungs. When you take air into the lungs, it is what? Inhalation. You are inhaling. When you take air out, it is exhale. You see here, air is moving into the lungs and the breathing system. You are inhaling. Into, inhale, in. It's going inside. And we all know that when we deal with the human beings or animal species, this air that is taken in is oxygen, and the air that is taken out is carbon dioxide. So the process of taking air into the lungs is inhalation. But if the question was saying the process of taking air out of the lungs, it would be exhalation. Are you still together with me? Then next up, which processes in 1, 2, and 3 are part of breathing? Which processes 1, 2, or 3 are part of breathing? I'll wait for an answer from you. Guys, which processes involve breathing? Or am I putting you on the spot? Let me go and give you the answer then. Next time I'll give you such activities as homework, and then we'll mark together in class. Né? Which processes in 1, 2, and 3 are part of breathing? Remember we described cellular respiration, gaseous exchange, and inhalation. All three are part of breathing. Why? Inhalation takes the fresh air to the lungs, where gaseous exchange through diffusion takes place. Remember, gaseous exchange happens where? At a respiratory surface. That respiratory surface is the one on the lungs. Then what happens there? There's diffusion that takes place. Then the blood then carries the oxygen to the cells for cellular respiration. So all these processes are connected and linked. The main point of us discussing all these three terms is so that we do not confuse them, so that we understand the differences between them. Yes, they are connected, but they are not the same thing. So when you inhale, you take the fresh air into the lungs, then gaseous exchange will occur at the lungs there with the surface, respiratory surface there, which is that lung. Through what? Through the process of diffusion. Gaseous exchange occurs through diffusion. Then, now that has the gases have diffused in that surface area in the blood then would carry the oxygen to the cells for cellular respiration. And then number 5, do amoebas breathe? Explain. Yes, amoebas breathe by diffusion through the body surface membrane. Remember amoebas? Let me go. I want to show you an amoeba. I'm going to Google an amoeba here and we'll look at it together for those who may not remember, and why probably this question might be asked. But let me share the screen. Yes, you see the amoeba over here. You see the diagram of the amoebas. You see it? You see the different diagrams, but it's basically the similar structure of an amoeba. It's like what? It's like, what can I, it's like spilled water. Né? Let's just say you spilled water or oil on its surface. It would look like that, a similar shape. Then amoeba would be shaped like that. Now, why this question over here? Do amoebas breathe? Explain. Yes, they breathe by diffusion through the body surface membrane. That body surface. Remember the properties, last week we discussed the properties or the requirements for gaseous exchange, the requirements for organs involved in gaseous exchange. We discussed those, and we've seen that it needs to have a large surface area, and they need to be thin in structure. So fortunately, amoebas are thin in structure, they have a large surface area, so it's easy for breathing to take place over there. And then, does a flatworm have a respiratory system? A flatworm. Should I show you a flatworm as well, or you know a flatworm? Let's go look for one. I want to go search for a flatworm for you. Can you see my screens? Okay, I think I closed the screen. Oh, I'm back. There's the flatworm. Flatworm. Do you see how flat it is? That's how flat. It's literally really flat there. These are flatworms. So the word describes it correctly. It's flat. Those are all examples of flatworms. Flat. I was just trying to show you so it can be clearer as we learn. So, do flatworms have a respiratory system? No. Due to its flat body shape, gaseous exchange takes place by diffusion between the air and the thin body surface membrane. So it means here, unlike us human beings and other animals, you might need a respiratory system because our bodies aren't so flat, so diffusion wouldn't take place easily. It's not like the oxygen can come out from the environment and directly into your lungs. You need a respiratory system where you breathe in that air and then it is transported to the lungs. You understand? Our system is more complicated like that. But with this one over here, it doesn't need a respiratory system because the whole point of the respiratory system is for what? It's so that the gases can be transported easily and then cellular respiration occurs, right? But now you will not need a respiratory system. That means you don't need to be able to breathe if your body is that flat, and gaseous exchange can easily occur by diffusion between air and this thin body surface membrane. Same way with the plants. Plants do not have a respiratory system. Why? Because the leaves are that flat. So the air can easily be transmitted through diffusion inside those particular exchange organs, in gaseous exchange organs in that particular organism or in that structure. But for animals, diffusion can't just take place because our structures are more complex. We have various other organs that are separating the lungs, which are actually the ones required for gaseous exchange. So if our lungs were maybe on our arms, on our sleeves, just on the skin, then yes, that could happen. But it can't happen because they're inside, so diffusion can't just take place like that. That is why we would have a respiratory system. And that's why other organisms such as flatworms do not need a respiratory system because of that. So you understand that the reason we are breathing, we are breathing and we need the system to allow us to breathe is so that there could be a process of gaseous exchange and cellular respiration which will take place. But you wouldn't need all that processes if your structure was thin enough and wide enough. I hope that is clear, and that explains why flatworms do not have a respiratory system, but us human beings have the respiratory system. And then, do plants respire? What does respire mean? They respirate. Do they respire? And we motivate our answer. Why are we saying there is? So you remember, look at this, it's 3 marks. So you need to provide your answer, which is a yes or a no. And then you what? You motivate. So yes, they respire. Why? They need oxygen for aerobic respiration. Why do plants require the oxygen for aerobic respiration? The plants, they need to also be able to produce more food for themselves and for us too. So they need that. So we need the gaseous exchange. Even it's the gaseous exchange in the process of respiration plays a major role as well in the processes of food production or food breaking down, because animals can't produce food for themselves. They'll need it for food breaking down. For plants, they will need it for food production. And then 8, say why a hydra does not need a respiratory system. Do you know a hydra? I'm gonna, should I show you a hydra or let me go look for a hydra for you. Hydra. No, it's showing me a different hydra. I don't want the hydra they are showing me here. Let me use a different, yeah, there is the one we are looking for. There is the hydra. You see, it looks like a plant. Look at the structure of the hydra. You see these images, ne? They are clear. It looks like plants in a way. And then one might even confuse it with the jellyfish, but I think this is a clearer structure of a hydra. This here, there is the hydra. Let's see a labeled diagram of a hydra. It has a tentacles, it has a mouth, there's a gastrovascular activity over there, there's an epidermis, mesoglia, gastrodermis, and basal disc. That's a hydra over there. Why then does a hydra not need a respiratory system? Oxygen reaches the body cells by diffusion through the thin body wall. So that's usually the reason why an organism wouldn't need, this is why an organism wouldn't need a respiratory system. Is if, like we mentioned here, I think you're following the trend now, it's if it's thin and it is wide. So because of the thin body wall, diffusion is possible. So in order for an organism not to need a respiratory system, then it would need to have the gaseous exchange organ to be thin enough to allow the process, the conditions need to be conducive for diffusion. And then we also discussed, guys, the next activity here, we also discussed the processes of this that I've busy mentioning, the surface area. Surface area plays a big part in allowing the conditions to be diffusion conducive. Yes, so to allow the conditions to be diffusion conducive, then that is why here, this is an example, you need a thin surface area, which is one of the requirements for those organs. And the surface area to volume ratio must be conducive enough. So we compare these two now. We're comparing shape A, it's piled. There you are piling up these books. 5 books, they are piled together. 5 books of the same size are piled. Then here with shape B, it is flat. You have 5 books of the same size flat in a row. So you see here, you have literally the same books in this system, but the way you place them would affect the surface area and ultimately would affect how diffusion would take place. This here, because they're piled, now then they are thick. If you were to pour, let's say example, you pour water over here, chances are from the orange book, it wouldn't be wet. All the water will only finish off on the first 2 books, or even just on the 1 book only. Then the other books wouldn't be wet. But here, if you were to pour water over this surface, all the books would be wet because it's flat. So that's how the diffusion would take place. For diffusion to occur here, when diffusion occurs, so this is now relating it to diffusion. It's just an example. For diffusion to take place here, it would take too long for the gases to pass through here because it is thick. So maybe the gases would only just be stuck there at the second book and not be able to reach the very bottom book over there. But because this is thin, the gases can move in here. Just like the water, the gases can move in all of these different books easily. Then here, for an organism which has a flat surface like this, then diffusion can take place and it wouldn't need a respiratory system. Unlike us, ours is like this, it's stacked. Our bodies are stacked. You have lungs, you have bones, you have skin, you have all of those things which serve as barriers to this air or this oxygen that we need to take in and the carbon dioxide that needs to go out. You understand? So the formula for area, if should you ever be required to do calculations, area is what? Length times breadth. I know you might, this is not mathematics, you're in the right class, yes, it's life sciences, but yes, when we do this, you need to understand the calculations of area. When you calculate area, if we were given, let me try, we're not given any values here, so I wanna try and give you, let's say this is, because this is a rectangular shape, let's say this is 5 centimeters, 5 centimeters by 8, let's say this is 8 centimeters. With a rectangular shape, you know it's length times breadth, hence it's given to you like this. But if it was a different shape, it would be, if it was a square, it would be side by side. Guys, you understand these, right? It's basic things you've done now, and you're in grade 11 now. So those are things you know, and you do in your maths or maths lit classes. So if you were to calculate area, it would be our length is 8 centimeters and our breadth is 5 centimeters. 8 by 5 would be, what's your calculations there? I just want to quickly show you. 8 by 5, 8 by 5 is 40. 40 centimeters squared. 40 centimeters squared. 8 by 5 is 40 centimeters squared. And then this one flat over here, this here, remember we are just calculating, there's no volume we're doing here, it's just the length and the breadth, the area of the shape. That's the area. The area of this shape would differ now, guys. Why? Because it's all these now. The area of one book, yes, it might be 8 by 5, but because this book are packed in a row, we need to calculate the area of this new shape that has formed now because of this. You see? So it is a new calculation altogether. And then the volume, you need to find what is the height of these books. So let's assume the height here, maybe it's 14. Let's say it's 14 centimeters. It would be the length times breadth times the 14 now. It would be the 8 times 5 times 14, which is the height. Remember, height is three-dimensional. Volume is three-dimensional, but area is two-dimensional, hence the power of 2. Here, the answer would be a centimeter cubed. Then you would then compare surface area to volume ratio. it would be 40 is to 8 times 5 times 14 is what? Let me say 8 times 5 times 14, it's 560. 560, the volume here is 560 cubic centimeters. So the SI surface area to volume would be 40 is to 560. Then you would compare it with the one over here. This one here, we can clearly see that the volume would be less because the length isn't that much. The height, there's a shorter height compared to this one. But the area, there'd be a greater area, surface area, compared to this one. So you see, we are comparing it using numbers now. So you might be asked that question in exams. And this is from the textbook, like I said, Via Africa Life Sciences grade 11 textbook. This question is asked there. And then, do shapes A and B have the same proportions? The proportions in these shapes A and B, are they the same? No, they are not the same because the arrangements differ. That's what we discussed. The arrangements differ. Here they are piled, here they are put flat in a row. So because of the arrangements, it would affect what? The proportions, meaning the measurements as well when you calculate. And then which one has the greater surface area? Shape B. This shape B has a greater surface area. Why? If we had calculations, we could have done those calculations to compare. Why do we say it has a greater surface area? It has a long row and more surface is exposed, as opposed to those books that are piled together. They're taking up less space, meaning the area there is less. So that surface covered is only a little bit. And then which one has a greater surface area to volume ratio? Greater surface area to volume ratio would be shape B. It is a greater surface area to volume ratio, as opposed to shape A, which has a greater volume ratio to surface area because the volume is bigger than the surface area. You're following right, guys? Please stop me if you have any questions or I confuse you. Then number 4, how does the shape, rather the size, affect surface area to volume ratio? Explain. When there's more volume, there will be less surface area. Here, when there's more volume here, it means there's less surface area. What other example can I make? You let's say you want, okay, you pour water in a bowl. In a bowl, you pour water. Then put your hand in that bowl. Chances are the hand will be submerged in that water, right? Because there's greater volume there. The volume is more than the surface area. But take that same water that is in that bowl, pour it in a bathtub, then put your hand again. Your hand will not be submerged this time. Why? You have decreased the volume because now the bathtub is high, is much bigger. But you have what have you actually done? You have increased the surface area. And because of the increase in surface area, then it has that effect. So you understand the differences that I'm trying to show you here. Same way, like example I did last week. If you wanna cook, you're in a hurry, you wanna cook mashed potatoes, what do? You're in a hurry. You will need to chop them up into very, very thin or small pieces, rather. It would cook really fast, as opposed to boiling large pieces. Large pieces would take a lot more time because of the surface area. Is that clear, guys? I need to emphasize that part of surface area. So because of that surface area, diffusion then is affected. If the surface area is larger, then the air can move in and out easily because the surface area is large. But if it's thick, it's not possible for it to move in and out easily. Is that clear? That is that part. If we still, we don't have time. I almost started with tomorrow's lesson. But any questions, guys? You're still okay? Okay, if you're fine, then these are the links I told you about. The Snaplify app to access all CAPS textbooks, and the Via Africa Grade 11 Learner's Book. I use those ones. I don't know, hey Butle, I'm not sure if the X kit is there. I'll search it for you and I'll let you know tomorrow during class. Or if you are still holding, let me search quickly and see if I can find it, and then you can look for it. I'm searching, just wait for a bit. But we can stop the class now. It's Butle who's left, and I can just keep her on the line and whilst we check, because I'm done with the lesson. Butle, you can stay on whilst I look for you. No, I don't see the X kit. I only see the ACE it. And then there's the Oxford Zoom, the Via Africa, the Zoom, Oxford Zoom Via Africa for grade 11. I've seen there's more diverse for grade 12. For grade 12, there's literally a lot of diversity in their textbooks. And then there's this one. What's this? The Cambridge Pass. The Pass textbook. It's there as well. They also have, what's this book? Mind Action Series. Literally a lot of study and master. They have a lot of others, but I can't see X Kit. We'll have to search properly, and I'll tell you tomorrow more about it. Ne? But just search it. Go download the app. You'll see. You'll find a lot of other textbooks as well, not only for life sciences, for other subjects as well. It will really, really help you. Okay, that is it from me today. Are you fine, Butle? Is everyone else fine? Thank you so much. We'll see you tomorrow as we continue with our topic. And tomorrow we'll deal with the human gaseous exchange. That's what we'll focus on tomorrow. And all the organs involved in that and how they do the whole process of gaseous exchange. All right, guys. Bye. Enjoy.